All right. Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Unwafe. Previously, we discussed on the topic Atex electric motor design and installation. On that topic, on the first section of that topic, we were able to calculate MCB rating, which is miniature circuit breaker rating, contactor rating, and overload relay rating. Now, today, we are going to discuss on same Atex electrical motor soft starter. Motor soft starter is an electrical device used to control the acceleration and deceleration of an electric motor during a startup and shutdown. It is primarily used with AC induction motor to reduce mechanical stress and electrical peak current, thereby enhancing the lifespan of the motor and connecting equipment. There are roles this very particular motor plays. And one of these roles is to control the motor startup. Instead of applying a full voltage instantly, it gradually increases the voltage, allowing the motor to ramp up smoothly to full speed. Another thing he does is to reduce the inrush current. The motor typically draws 6 to 8 times their rated current during startup. So a soft starter limits this inrush current, reducing the stress on the electrical network and avoiding the voltage dip. Another role he plays is the torque control. By controlling the voltage, the soft starter also manages the torque output, which is crucial for application involving belt, gear, or fragile mechanical systems. And most importantly, a smooth stop functional. Some of the soft starter also provide a controlled deceleration, preventing abrupt stop that could damage an equipment or cause a product spillage in process industry. It is basically for a flammable product. Now, if you look at the picture on the slide, you can see a picture of this soft starter. On this soft starter, you have the input terminal terminated at TL1, TL2, TL3 in 3 phases. While you have the signal, which is the input signal for SI, for startup and stop of the current. Then also, you also have the acceleration and the deceleration setting. Then there are other factors that is already stated here that we need to know. And as we go on, we will be able to know how to operate and how to calculate and how to adjust and connect properly. Now, soft starter component. Inside the soft starter that you just saw previously, there are different components inside, as you can see on the diagram. One of the components is a bypass contactor. A bypass contactor, it functions as the motor reaches a full speed. A bypass contactor closes by bypass the soft starter. The purpose of it is to reduce the heat and power in the soft starter by allowing the full current to flow directly to the motor. We have the rectifier. The rectifier function as converting the AC towards DC. And the purpose of it is to often use in confirming the circuit in DC motor circuit starter. Then we have the thermal LED, which is known as a thermal overload relay, which functions as protecting the motor from overloading due to excessive current. And the purpose of it is to monitor the current and trip the circuit with the motor when the motor is overloaded. Then we have the thyristor. The thyristor also functions as a switch to control the voltage supply to the motor. And the purpose of it is to gradually increase the voltage during the startup to reduce an inrush current. While we have the most importantly, CC arrow configuration. This CC arrow configuration is a type of thyristor that uses in a pair to control each plan of the what? Each phase of the AC supply. Now, it functions in form of the stop and the start button. Now, there is a need for also to know the size of a substarter that we need to use. And for us to know the size, we have to note that to ensure a reliable and efficient operation, it is crucial to properly size a substarter in accordance with the motor specification. Now, in every substarter, in every motor, there are specifications on the nameplate. Now, assuming, let's take this scenario. Assuming they supplied a motor to for installation in a site, and on that nameplate you have 5 kilowatts rating, and a phase is 3-phase. You also have the voltage to be 400 volts, while the power factor to be 0.85. Then the frequency to be 50 to 60 hertz. So now let's take step-by-step way of calculating the sizing of this substarter. Now, to size this, you have to introduce this formula by first calculating the full load current. The full load current is equal to power factors all over root of 3 times voltage times power factor. Now, 5,000, when you substitute the power, which is 5,000, all over the root of 3, which is 1.732, multiplied by the voltage, multiplied by the what they call a power factor, which is 0.85, is going to give you 8.499. Considering this safety factor, which is a standard factor, you multiplying with this safety factor, is going to give you 2.12. Now you add your safety factor, which is 2.12, to the actual FLC, which is the full load current, which is going to give you 11 amps. When selecting this substarter, kindly select the substarter within this range of 11 amps to 12 amps in adjustment. Now, if you look at this substarter, there are certain devices, just like we rightly said previously, that there are certain devices that you have to set. On this very calculation, based on this calculation, you have to set your motor current in line with the current factors. You also set your ramp up time. Then you set up your trip class. Then above all, you set up your current limit. After all this setting, you will ensure the efficiency and the functionality of that substarter in protecting the motor to work effectively. I want you to share this video so that others can as well gain knowledge. Thank you.